Hello. In this video, we're going to be talking more about linear equations. We already have an idea of slope and the slope-intercept form for the equation of a line. Here we're going to be seeing different kinds of ways of writing the equation of a line that could be useful in other contexts, and then also some information about how slopes of lines are related. And that's the essential understanding that's coming up towards the end. The slopes of two lines in the same plane indicate how the lines are related. If we notice certain relationships between slopes, we know something about the lines, but that comes a little bit later. So here's one thing we want to know. It is what's called the point slope form of the equation of a line. Right? When we have a line, we can actually write the equation a lot of different ways depending upon what information we have or what we want to do. So point slope form, it has that name because basically we use a single point and the slope. So the point is x1 comma y1, and the slope is m, and the equation looks like this. So it's y, the variable y, minus y1, a particular y coordinate of a known point, equals slope times, and let's emphasize these parentheses, x minus the specific x coordinate. So this is usually the easiest way to write down the equation of a line. If you're not given a specific form, this is the one to do right away, usually. And even if you want a different form, maybe starting with this one is easiest. Just to be clear, x1 and y1 are going to be particular specific numbers in any example we do. While x and y are what are called formal variables, even when we are done and have presented the final equation, it's going to have an x and a y in it. And also, do not forget these parentheses. If you leave them out, your equation has a different meaning. So let's look at an example. Suppose that I tell you that a line has a slope of 3, and that line passes through the point negative 1, 4. Right, we could draw a very rough picture here. Negative 1, 4 is something like this. A slope of 3 means it's rising about 3 times as fast as it's moving across. Once I have this information, a point and a slope, I can get the equation pretty much instantly by using this form. My specific x coordinate is negative 1. My specific y coordinate of that known point is 4. Make sure these are from the same point. Even if you know multiple points, they have to be coordinates from the same point. And my slope is 3. So I can just insert things into this form. Y, the formal variable y, minus the coordinate y1 equals the slope times, in parentheses, the formal variable x minus negative 1. And if we clean that up just a little bit, x minus negative 1 is x plus 1. So this is our equation in point slope form. Almost instant, given the information we had. Now, if we also wanted to know what this is in slope-intercept form, maybe we want to find the y-intercept, we can just do a little bit of algebra. So the first thing I'll do is I'll distribute that 3. Then to get y all by itself, I'll add 4 to each side, and we have y equals 3x plus 7. There it is. If y is all by itself, and we've cleaned up the right-hand side, we have it in slope-intercept form. And our y-intercept is 7. So make sure you know this form. It's really handy. In calculus, this is the form I use most often. If the instruction is just write an equation and no one says you have to put it in a specific form, this is often the best one. Another form you should know is what's called standard form. So standard form is when we put x and y on the same side of the equation. So it's just some number times x plus some number times y equals some number, where a and b, these coefficients, are not both 0. So a, b, and c are going to be specific numbers. X and y are formal variables. So we now know 3 forms. So the first one we talked about was slope-intercept, And that's usually the easiest one to use. If you want to graph the line, it tells you the slope and it tells you the y-intercept, which is a really handy form. With point-slope form, we noticed that that was probably the easiest one to figure out. Right? If somebody asks you to write down the equation of a line, point-slope is probably the one you'll be able to come up with first. And then what standard form has going for it is that it's the most elegant. It has the simplest looking equation. Usually we set it up so that there are no parentheses or fractions. It's the cleanest looking, although it's not necessarily the most useful. So as an example, let's convert to standard form, right? We want to be comfortable converting between these. So this previous example was y equals 3x plus 7 after we changed it. So, So y equals 3x plus 7. In standard form, we want the x's and y's on the same side of the equation and then a number on the other side. So what we could do here is we could subtract 3x from each side, and we would have negative 3x plus y equals 7. It might not look natural to start with a negative like that, but that's fine. If you wanted to, you could multiply everything by negative 1, and it would look like this. Some people might prefer this. Either one of these would be an example of standard form. X's and y's are together on one side of the equation, and then there's a number on the other side. In this next example, we have something in standard form, and we want to convert it to slope-intercept form. So slope-intercept form will have the y by itself. So we need to do a little bit of algebra to get that. So first, I will subtract 2x from each side. And I'm writing the negative 2x first because usually that comes first. Now we're going to divide everything by 5, and that means we have to divide each term by 5. We're going to divide this by 5. We're going to divide this by 5, and we're going to divide this by 5. So it will look like y equals negative 2x over 5 plus 7 over 5. And the way we write that, that looks exactly like slope-intercept form, is that we put this fraction in front of the x. Negative 2x over 5 and the number negative 2/5 multiplied by x have the same meaning, but this form here is what we would consider slope-intercept form. So the slope, we can read that right off this equation, is negative 2/5, and the y-intercept is 7/5, which is 1.4. This is negative 0.4. Sometimes fractions are not the most helpful. So you're going to have a lot of homework practice just getting used to these forms and moving between them. Now, what about parallel lines? If I draw two parallel lines, parallel, right, there's a definition in geometry that's slightly different, but when we see parallel lines, we think they're equally steep. And slope measures steepness, so these lines should have the same slope. That seems to be what's going on. While if I have perpendicular lines, let's look at the relationship here. These definitely do not have the same slope, right? That's a 90-degree angle, more or less. So we're noticing these slopes are different in a couple of ways. So this slope appears to be a small positive slope, right? It's going up, but it's going up rather slowly. And then this would be a big negative. And by big negative, I mean a negative number far away from 0. It's going down rather steeply. So those slopes are opposite in two different ways. One of them is close to 0 and one of them is not close to 0. And one of them is positive and the other is negative. We can formalize that relationship here. So here are the two facts you want to know. The slopes of parallel lines are equal, right? That's easy enough. They have the same steepness. The slope measures the steepness, so the slopes are the same. Now for perpendicular lines, it's a little more complicated. The slopes are what are called negative reciprocals. So let's just look at some examples. Negative reciprocals are numbers where one is positive and one is negative, but otherwise they're reciprocals. So 3 and negative 1/3. Negative 2/5 and positive 5/2. 1/4 and negative 4. One thing that I'll just point out is if you multiply these together, you get the number -1. So let's do a little example here. Suppose we have the line y, 3/2 x plus 3. So I'm just going to draw a very rough picture to wrap my head around this. It has a y-intercept of 3 and a slope of 3/2, which means it's a little bit on the steep side compared to average, but not super duper steep. And then I have the point here, -1/7. So presumably, I can imagine one line through that blue point that's parallel to the given line, and a different one that's perpendicular. So I want to know what are the equations of these two new lines. All right, well, this shouldn't be too hard. What do we know about the given line? The given line has a slope of 3/2. So for the parallel line over here, the slope is the same. It's also 3/2. For the perpendicular line, it's the opposite or negative reciprocal, so -2/3. And this point right here is at -1/7. So take a look at this and ask yourself, of the different ways of writing an equation for a line, which would be fastest in this example? Well, for the green line, we know a point and a slope. For the red line, we know a point and a slope. Let's use point-slope form. So the parallel line would be y minus the given y coordinate is equal to the slope times, in parentheses, x minus my given x coordinate. And canceling that double negative is probably worth it. We'll do the same thing for that perpendicular line. Y minus the given y coordinate is the slope. The perpendicular red line has a slope of -2/3 times, x minus -1, which I'll immediately simplify to x plus 1 again. I'm doing this very fast in the video. You're going to need to practice this a lot, but the rules are not super complicated. Now, one thing that I kind of skipped over here is these rules about parallel and perpendicular lines don't apply if we're dealing with vertical lines. A vertical line doesn't have a slope. If you try to calculate the slope, you get an impossible calculation. But we can still talk about vertical lines. They exist and they have equations. So think about a horizontal line and a vertical line. Let's suppose here are my x and y axes. Let's suppose here's the point 1, 3. There's a horizontal line like this going through that point. And there's a vertical line like this going through that point. Can we come up with equations for these lines? They're actually very easy. And some students get tripped up because these equations are so easy that they feel hard. They're unfamiliar because they're so simple. Let's look at this pink line. What are some other points on this pink line? Right, over here we would have 6, 3 and 7, 3 and -1, 3. All of these points on the pink line have a y coordinate of 3. So the super simple equation y equals 3 describes every point on that line. Equations of lines, equations of curves are just descriptions of the points that live on that line. We can describe every point on that line by simply saying its y-coordinate is 3. Similarly, along this vertical line, here's 1 comma 1, here's 1 comma negative 1, here's 1 comma 5. We can describe all of those points by just saying the x-coordinate is 1, period. It might not look like those other forms. It's technically standard form, but it's super simple. X equals 1 describes everything on that line, end of story. So this is worth remembering. If you have an equation line, if you have a horizontal line, its equation will just look like y equals some specific number. Every point on that horizontal line has the same y-coordinate. Y equals that number is your equation. And similarly, the equation for a vertical line will look like x equals some specific number. Okay, that is it for this section.